Welcome back to Percona Live Online and our Day 2 keynotes. Just a reminder that if you have any questions for the presenters, feel free to pop them into the chat to the right of your screen. Our first presenter, Kaj Arnö, CEO of the MariaDB Foundation, is a longtime supporter and speaker at Percona Live. Kaj will be presenting on collaboration and open source, a jungle that needs structure. Take it away, Kaj.
Collaboration in open source. That's a jungle that needs structure, if you ask me. I'm Kaj Arnö, the CEO of the MariaDB Foundation, and I will look at MariaDB's use of Jira, Github, Zulip, WordPress, YouTube, Knowledgebase, other tools for creating collaboration. So the agenda here is starting from a Swedish proverb. If you heat your house and do not get the warmth into the house and instead it gets outside, it's called that you're heating for the crows, meaning doing stuff in vain. Now, what we want to avoid is coding for the crows, meaning we want to write code that does correspond to the needs of the users and will get used. So that is our goal, to code for the crowds with a D and not the crowds. So going into the detail here in the presentation, we will talk about how to design collaboration and communication to support the development process, how to go with the flow, how to set expectations, how to meet expectations, and especially how to balance contributors and roadmap input from various sources. The scope here is non-urgent situations or new development. Outside the scope is the process for, shall we say, bad regression bugs. That's a different topic, and that's something that doesn't occur all that often. So our tool set at the MariaDB Foundation for this is 5 different tools mainly. GitHub for the code repository. It's the world's largest code repository, no explanation needed. Jira as an issue and project tracker. That's also an industry standard, probably doesn't need much introduction. WordPress, well, everybody does blogs with WordPress, so that's another industry standard. What we do for group chat is Zulip. So that's best described as an open source Slack alternative, not as much of a standard as the others. And the last item here in our toolbox is the Knowledgebase, which we use for documentation, and that's a homegrown thing. In that sense, you could say it's non-standard, and the standards for how to do documentation, I believe, are still emerging. The end outcome here should be us listening to you, the users, of your input of what we should be doing. So here's a list. You can't see the details of it, but it's a long list from Jira, ranked by how many votes a Jira item has got, and if you would look at the details, you would see that the top 5, 6 are scheduled for a particular release, and this is a type of a list that we follow in order to make sure that we do code for the crowds. Looking at an example here is JSON table, a feature that will enter into MariaDB 10.6. And that's something that many people have voted for or watched on Jira. So 31 votes for the issue and 32 people watching it. And that's your best way of influencing us, because we do listen. We have a fairly okay track record in fixing the most voted for and watched issues. So this openness of listening and doing what's needed is a specific goal of ours. So MariaDB Foundation is about the adoption of MariaDB Server and about its openness, the openness of the code base. And that, of course, has to be reflected by the tools we use. So in GitHub, this means that we want pull requests, we want contributions. In Jira, it means we want votes and watches, and we want comments on whether the specs are okay. In WordPress, at least we want readers. Whether that's the right place to comment or not, I'm not quite as certain, because the structure comments that then feed into particular features come best through Jira. And the discussions, which are interactive, they best happen over a chat tool, in our case, Zulip. And in the case of the knowledge-based documentation, we want not just readers, but also contributors, and people can ask questions on the knowledge base. There are, of course, other tools for openness. So Stack Overflow exists. We do polls, and we have YouTube videos. Of course, we're active on social media, and we do Billboard for continuous integration. So openness is not just the 5 tools that I'm concentrating on here. Traditionally, we've separated our audience into 2 types of developers, users and developers. So users of MariaDB Server, they are developers of their own applications, and the developers are the ones in our traditional lingo that develop MariaDB Server itself. One can ask, though, whether that is a meaningful distinction. So first of all, the development effort can be moved between the 2. So we can move, or the user can move the application effort off the application development to database development, which was done, for instance, by DBS Bank when they wanted to migrate their Oracle applications relying on PL SQL instead of recoding them with a standard stored procedures language. A very big subset of PL SQL was implemented into MariaDB Server itself. And then there's the other reason for the distinction not to be quite as meaningful, and that is that some top-level users absolutely, although they do not develop the server itself, have a very detailed input on how the Jira items should be specified, what the roadmap exactly should be. An example of this would be Wikimedia Foundation, with a lot of discussions on both features and things that border between bugs and features. So the target groups overlap, and our openness tools are definitely directed also at users, meaning you as the audience here at Percona Live. So this slide about the fallacies and challenges that are psychological is one that is based on a lot of experience and thinking, and it is soft information. It's not absolute, but I think it's the result of lots of thinking. So the first item here is on the messenger bias. So let's say we have a crashing bug, and the same crashing bug would have been discovered internally, or we would have been alerted to it by an external source. Well, you can guess which one is more important. As soon as the messenger is external, the credibility of the report is much, much higher, and people have a tendency then to give it much more attention. Also, inside the organizations, the internal messengers have a different status. So whether a junior developer says something doesn't mean it's going to get the same attention that as the same report would get, thought would get from the founder. And you can call that negatively as politics, but you can equally well use a positive term like diplomacy for it. So our goal here is to ensure that we focus on the urgent, not just on the urgent, but really on the important, because the human tendency is to focus on the urgent. Then we have a tricky thing, which is mostly an asset, and that's the potential issue of founder cult. So good organizations have a good founder who provides the developers with lots of energy and insight. And we are blessed with such a situation at MariaDB. But that also has a flip side, and that's the fact that nobody is immune against worship. So flattery will get your way perhaps more also, and not just logic. And this internally also has an effect. Of course, if there is a founder who has lots of insight and is not necessarily part of the line of command, it influences both the roadmap and the actual to-do list of individual developers. So what we as an organization need to understand is to not bypass the line of command while at the same time benefiting from the insight from a founder. And that this, I tell you, not just as a sneak view into the inside of our organization. I think it's a a good role model to work like that, and also you will understand some of the priority settings better if you're aware of this. The third item here is about attention and information overload, which we all suffer from. And I'm looking here at the overload and difficulty of directing attention both for the users of MariaDB as well as internally for us. So from our perspective, it's about how to direct the attention of the users to the right Jira entries and pull requests and blogs, both our attention and that of the users. And the tool here is to improve the signal-to-noise ratio in all tools. So for instance, let's use the right tool. So chatting is best done in Zulip, but that chat does need a summary for the specification of the feature that was discussed. So somebody needs to ensure that the end outcome of the discussion is documented well in Jira and concisely. And then there's a very, very tricky fallacy, and that's the only code matters or only new code matters stuff, where developers tend to over-prioritize development. And what that means in practice is that we have lots and lots of features in MariaDB which are not being used to the extent that people would want to use them if they only were aware. So you can blame marketing on this for not creating enough awareness, but I think that's the wrong thing, the wrong scapegoat. The developers themselves need to inspire the users about their own features and need to evangelize the features so that they will actually be used, and that is a journey that starts from understanding that the specifications or whether the specifications actually meet with the needs of the users. So some tentative solutions to this dilemma. One is to design feedback loops in such a way that the external input about urgency give us the same signals as the important goals are. So they reinforce the top level goals and improve then also the specifications so that we get it right. And this feedback loop can go all the way to the end user who is very distant from the developers. The usual way to find a solution to a problem for any of us as developers using any tool is to Google, and then we often end up on Stack Overflow. So the right feedback loop there is for us to listen to Stack Overflow input and not just use it as input, also use it as outputs. There's an example here on the MariaDB InnoDB buffer pool, a load taking too long of a time, and that ended up in Jira. And we did not just document it in Jira, but there's an answer to the Stack Overflow person issue here item. Another solution here is to cross-link between the tools. So, of course, the same things are being discussed on Zulip, on Jira, and in pull requests. So those who end up in one of those need pointers to the other places, meaning cross-linking Knowledgebase posts for the actual documentation to Jira, which contain the specifications of it. In the case of Google Summer of Code, where we have activity in MariaDB, there's a Knowledgebase post pointing to many Jira links as an example. And this is a particularly good thing to integrate with social media and blogs. And then for us, I think the right solution, as for anybody, is to go where the developers actually are. We don't want to make it hard for people to find us. Yes, our documentation is on the Knowledgebase, and that is not the default place for people to go. They, by default, Google, but then the Google pages or the Stack Overflow entries should point to the Knowledgebase. People expect stuff to, as a contributor, to be on GitHub, so let's have the type of interface on GitHub and the specifications and the files that people expect to be on GitHub. And as for getting MariaDB itself, what people expect is a Docker image. So let's make that one good. There's, of course, challenges still remaining, the overlap between the tools. So people might want us to do more on GitHub than we do. Well, we do our specifications and bugs still on Jira. GitHub is currently only the code repository. The Knowledgebase I mentioned, we have interactivity on it. You can ask questions there, and those questions will get answered. In some time, they will directly on the Knowledgebase. And that also then feeds the roadmap at some level. We have semi-related projects, other MariaDB stuff, the MariaDB Server and the scripts, and they might have their documentation elsewhere. An issue that you might face indirectly is inconsistent developer input for new features. So when we document the new features, it of course depends on the type of input that we get from our developers, and that's not always the same. So that's something which you will see in the form of varying quality of different knowledge base articles. And the challenge for us is to manage redundancy. So if we want to have cross-linking and if we want to be present where you are, it also means that the same information needs to be in several different places, which has us having to find the right balance between making it easy to find for you and making it possible to update and maintain for us. A semi-internal difficulty here, which I think other organizations face as well, is to take blogs seriously and to take blogs in the right way. So sometimes we take blogs too seriously. A developer might think, I don't want to blog about this feature because it's not done yet, it's not ready yet. And the end user will expect that as soon as I blog about it, within a month they will want to use it. I think that's not the right way to think. I think that is equal to not taking blogs seriously enough. So if we believe that we need to have a ready-made feature to blog and otherwise we'll do development instead, well, that precludes the possibility of having the feedback loop related to the specifications. Because if a feature is ready to be used within a month, you can't really expect us to take your input on the specifications and have that changed into the same release. So the feedback loop needs to happen earlier. So I think the right perspective is to look at the voyage of a feature, starting from an idea, going to a Jira item, and then into a well-documented feature on Knowledgebase with videos and talks on conferences to support it. So the right way, I believe, to use blogs is to create buzz and then pressure to get a review, drive attention for both internal readers and external readers, users, asking for feedback back, and thereby achieving awareness so that we do not code for the crowds, and that the crowds, meaning the users, we can create value for the users. And our ideal scenario is, of course, that the blogging is taken so seriously by the end users that they test new features, they benchmark them, and they, meaning you, blog about their experience. So all of this wouldn't be possible if we didn't have our MariaDB Foundation sponsors. So these are our sponsors that support the development of the MariaDB Foundation. The platinum level ones, Alibaba, Tencent, Microsoft, MariaDB Corporation and ServiceNow. The gold level sponsors, DBS Bank, Visma and IBM. So let me conclude by a request for you, and that is to help us improve our collaboration. This was very much a short broadcasting chat about how we believe that we should do things, but that the more important thing is whether we do it the way that you expect us to do. So do we meet your expectations? Do we set the expectations on upcoming features properly or on existing features? Are we present where you hang around? Do we make it easy for you to use us and to contribute to us? So the best way for you to answer these questions for us is to hang around at the MariaDB community room, which we have coming up here at Percona Live. And if you want to do this later on, email us at foundation@mariadb.org or me personally at kaj@mariadb.org. So this is our way of thinking about structuring the jungle of collaboration in open source using Jira, GitHub, Zulip, WordPress, Knowledgebase. I'm Kaj Arnö, the CEO of the MariaDB Foundation. Thank you.
Thank you, Kaj, for taking time to share this presentation with us, and we appreciate all that you do for open source. Our next speaker is also a familiar face to many, Frédéric Descamps from Oracle, affectionately known as LaFred, will be presenting his annual State of the Dolphin, including the latest updates on MySQL 8.
Hello, welcome to the State of the Dolphin. I'm very happy to give you some news on MySQL and of course MySQL 8. First slide, the safe harbor statement. I don't have a lot of time for this keynote, so please read it later. Who am I? Very short introduction. My name is Frédéric Descamps. I'm MySQL Community Manager here in MySQL team. So you can follow me on Twitter at LaFred. I'm living in Belgium and I have a blog post with a lot of information about MySQL. So where are we in 2021? So in 2021, MySQL 8.25, yes, you read it right, 8.25. This is the latest release. It's a very fresh. So more information about that later in this keynote. 2021, as you can see in the DB Engine database ranking, MySQL is still the most open source popular database. So we are very happy. And also, but this is the one of 2020. 2021 is not yet available, but for the Stack Overflow survey with developer, we can see that MySQL is the most popular database with developer. So we are also very proud of that. So something also very important now certainly in this time and 2021 is that MySQL, it's open source and is GPL, and every component are GPL, as you can see. So we don't change license. Like we have seen some a lot of information related to that everywhere. So don't worry, MySQL is GPL, and we accept contribution. More with that also at the end of the session. So what's new since the last State of the Dolphin we did here at Percona Live in October? 3 releases. So 8.23, 8.24, and 8.25. So I will give you a small overview of these releases. I won't go into the details everywhere, but I will give you some very key features or modification with it. So for 8.23, we have invisible columns. So this is a very key changer. I will show you some example in a few slides. So invisible column since 8.23. Query attributes. We also, like usual, pay attention on security, and we now encrypt override files, and we have also more granularity for the flush privilege. Like every release we do, we have also new GIS function. Also, we have optimized hash table in hash join, right? So with the implementation of the hash table used in the hash join, right? This is the purpose of this was to improve the performance and use less memory, and of course improve the memory control. So user don't see it, but in the background there are modifications here. Also in DB, this time we have faster truncate and drop table space. It's much faster one, so I recommend you to have a look at it. And you can also auto extend. You set the auto extend per table space. And we improved temp table, the temporary engine. So we also did a lot of refactoring, and users don't see it, but our developers were busy with that. So what have we done? So we extend the internal server infrastructure, and we also converted all the atomics to C++11 now. I told you we have invisible columns. Let's have a look to what it is. So if I want to check the table that don't have any primary key, so we can see here, oh, no primary key. And I think primary key is very important for InnoDB, but also for replication and so on. So if you have more information on that, we can talk later. So what I can see that test database, the table T1 has no primary key. So let's have a look at it. We can see it's true. We don't have any primary key. So let's change this. So we do an alter table, and we add an invisible column now that we're going to use as primary key. So this is how we do that. So for the application, nothing changed. The table is exactly the same. They don't see the primary key, but this is perfect for replication now, because replication will be able to use the primary key to not do scans to find the records, for example. So as you can see, application, no changes, but this primary key now is exposed if you want it and used everywhere. And this is very, very important also for group replication where primary keys are mandatory. So in 8.23, we also work and keep working on replacing the old terms. So this offensive term that we don't want to see anymore in MySQL. So 8.23, we did several changes on that and on the commands too. You may have noticed that. And also something very interesting is that we allow replication from a machine without a source, without a GTID to a replica where GTIDs are enabled. And something very important also is that now the asynchronous connection failover also support group replication, right? So let's have a look at this particular feature because it's very interesting. So we can call a UDF to create this manage failover connection where we give a name and then we say what type of it. So we say, okay, we're going to be the replica of a source, which is a group replication. We give the ID of the group replication. We connect to one of the node and we give a weight like 80 for the primary and 60 for the other ones. And then we can create our replica. So this is how we create the replica. So we do the channel we have here. So I think from IDC, for example, and all it's there now. We can start the channel. And as you can see, the new terms here, start replica for channel. And it's there. Performance schema, you can have information about that. And we can see which nodes now are part of the failover mechanism. So what does that really mean? So it means that now, when we have this architecture where we have an asynchronous replica that can be used for disaster recovery, for example, from a group, the cluster group application, when the primary has an issue, crash or whatever, and this asynchronous link stop to work, automatically the replica will point to the new primary. So all this is automated and automatic and transparent. So it's very nice. So we work on the server, but we also, our developer were working a lot on the shell. So we enhance import table, we enhance the admin API for 802.23, and we also improve the router, which this time supports TLS endpoints for the routing connection. So 802.23, then 802.24. So 802.24, we have this improvement in the optimizer, right? Where to make it simple, the materialize subquery is materialized only once now, and this is much better for performance. Like I said, usually we have new function again in GIS, and also we have a cast between geometry types, which is very interesting too. We have also more instrumentation for data dictionary and runtime code. In ODB, now we can also control the donor timeout when there is a network failure. So also very important when we deploy in ODB cluster, for example. And we also add a new feature in security. And for example, we migrate the queuing API to a component infrastructure now, right? Now we have better messages when the client got error on wait timeout. Like usual, we work on replication, and now, for example, now you can have a skip replication as a global persistible read-only variable. So we can use subpersist to modify the value of it. And in group replication, also something very useful. Now you have the IP allow list that is modified when group replication is still running. Again, shell, we improve the command line integration with arrays and stuff. Follow my blog if you want more information about that. Dump and load was wonderful, and we keep enhancing it. So the team makes a wonderful work on that. And we also improve logging with syslog and stuff like that. And router now, we only accept connection if there are destination available. If not, no need for that. So I was telling about this dump and load enhancement in the dump, just to refresh your mind here. So if you want to do a logical dump, don't think anything else than MySQL shell dump and load utility. Stop the others. As you can see here, we are much faster and everything in parallel. So this is a dump. You can see the ping one, it's MySQL shell and dump. Very fast to dump, but also very fast to load, right? And as you can see, there is no contest here. MySQL shell dump and load, it's very, very fast. And look at this difference. And this was with 8. So these benchmarks are from 8.21. So now it's even faster. Just because it's cool, I want to show you 65 gigabyte, one single table in one schema, of course. I was loading it, this 65 gigabyte in 3 minutes from one machine. So my shell was on one machine and the database is another one. So there is also network connectivity here. And you can see it's very, very fast. Something else also very cool that now in the when you do load shell and dump, because I was telling you about the invisible column that we can use as primary key, you can do a dump of schema without primary keys and load, and when you load it, create these invisible primary keys. So on 8.24, this is amazing. Like I said, 8.25, it's completely fresh. What is it? So this is an out-of-cycle release because we had a bug that we really wanted to fix, and we really wanted to fix it as soon as possible and not make our user wait for it. So it's there now. This is fixed. So this was an out-of-cycle release. But the MySQL team were not only busy with server, shell, router. We were also very busy with MDS, so MySQL Database Service on the CI, because as you know, this is 100% developed, managed, and supported by the MySQL team itself. And so what have we done there since last keynote, right? So we added more region. So you can deploy now MDS in much more different region compared to than October. Also, we added MDS Heatwave. So I don't know if you have seen it. If you didn't, I don't know where you were, but Heatwave, it's something very powerful in MDS. And as you can see, you can speed up dramatically your queries, right? 400 times faster. And so this is fire. And also, if we check Heatwave compare with MySQL Database Service, Heatwave compared to Amazon Aurora, you can see we get it sooner, of course, because MySQL it's you have always the latest, but it's sooner, meaning that your data it's much faster to be loaded to it. It's faster and it's cheaper. So once again, good. Redshift. So if we compare it, it's also faster and cheaper. So again, very good. But if you don't believe me, I can understand, and you want to improve your query, just sign up for a performance health check. So we can prove you that your query will be faster with MDS and Heatwave. Also, what have we done? So we added HA to MDS instance now. So we can distribute 3 instances, so across 3 different availability domains, across 3 different full domains, right? You can do switchover, meaning that it's manual, you plan for it, or you can do failover, it's automatic and unplanned. And how complicated it is to deploy the HA on MDS? One single button. You just say, oh, I want availability, and that's it. And of course, what are we using to do our HA? We are using group replication, right? So very fast summary, one single click, automatic failover, or manual if you want. This will increase your uptime. This is reduce your downtime. So RTO is just some minutes. And of course, RPO 0 with group replication, no data loss. We worked, of course, on easy solution, as you know. So we keep improving that. And these solutions are InnoDB cluster, right? And so this gives you HA with the full tolerance, and everything here is GPL and automated, right? And replica set. Replica set, it's for the people that are used to asynchronous replication and want to keep using asynchronous replication, but you can do it completely with the router, with the shell, and you can provision the data and everything. So this is, but this is not automatic, the failover, it's manual, right? What are the goals of this product is that all the components are together, they are integrated together, and it's all testing together. One single client to orchestrate everything is the shell, and all it's integrated, and it also support SNS, DNSSRV. There were a session about that today too. So if you have missed it, check it on demand. So this is just example how easy it is to deploy, but I don't have time to go there. And something also very woohoo, it's there, almost there, is that now in MySQL, we have the operator for Kubernetes that is by us, by the MySQL team. So we are busy working on that too, right? So give you automated deployment and management of MySQL, the server and the router. It's self-healing, it backup and restore, it supports all that, rolling upgrade with minimal downtime, and most important, developed and supported by the MySQL team itself. So public beta will be released in a few weeks, stay tuned, and this is how it looks like. So there were also a session about it. So if you have missed it, if you're interested in it, go on demand and check it. And finally, I want to thank all our contributors. Like I said, MySQL is GPL, MySQL allow contributions. So MySQL 8.0, it's 555 contributions so far. This one we're merging into MySQL 8. It's by 68 individual contributors. So no employee content, just the third parties contributors. And the top three are Facebook, Lorinas, and Daniel. So thank you very much, guys. These are all the contributors. So thank you, guys. Really appreciate what you are doing with MySQL, and our community is very good. So if you want to know more, or if you want to see on demand, this was the track of the MySQL community room here at Percona Live. Don't forget, we have now the possibility to get certified MySQL 8, DBA, and developer. All these are available. So thank you very much. I tried to make it on time. So thank you. Bye-bye, and enjoy. And you know how to find me.
Thank you, Fred. It's always good to have you with us at Percona Live. Our next presenter is Patrick McFadin from DataStax. Patrick is here to make a case for making the move from DBA to SRE.
Hi, everyone. My name is Patrick McFadin. I work at DataStax in developer relations. Today, I want to talk to database administrators about something very important about the future. So for you out there who are database administrators, hello. And I know there are a lot of you out there. And the reason I know this is because I'm one too. I've run into you several times in my career. My career started with an Oracle database running on a Sun server. And it was really cool, right? Because we had this Sun server. I had a Sun 450 underneath my desk, which was really cool. It had wheels on it. But I learned how to set up a database and run it in these really high performance environments. And it was really fun, and I enjoyed it so much. And it was really like during the time when databases were becoming such an important part of the internet. And eventually I started working with MySQL and more open source databases. And then finally, last 10 years, I've been working with Cassandra, Apache Cassandra, the open source NoSQL database. And all of these needed administration. I was happy to do that. I also worked a lot in other infrastructure projects, but at the core, I always loved data the most, and understanding those challenges was really an important part of my career. But times are changing, and that's why I want to talk to you today. Those times that I'm talking about are like just how things evolve over time with like jobs and skills, and especially roles. So here's an important number to throw out just the beginning. And this is the job title. I want to be very clear about this. So one of the people I work with, Corey Land, who's a researcher at DataStax, had helped me with some LinkedIn research. And this is recently done as of 4/11/2021. So this is the year-over-year growth of the DBA job title. Now, that's a job title. That means who has that job title on their LinkedIn. But a -0.7% decrease is kind of a bummer, right? Especially if your job role is DBA. But don't get too worried and don't freak out just yet, because the database administration skill, that skill like actually running a database, has been growing year over year by 15%. So running databases is still a very important skill. It's just that DBA role has changed quite a bit. Now, conversely, the site reliability engineering title, or SRE title, has been growing at 14%. So the title has been keeping up around about the same as the DBA or database administration skill. But here's an interesting statistic, and this popped on me real fast. And I saw this and I was like, wow, 74% growth year over year on the site reliability engineering skill. Now that's the skill. That means you may have a different job title. You could have chief database dude or something like that. That I've never really trusted the names of roles that people have on LinkedIn, but their skills, that's what's important. And if I look at this number and I say, yeah, 74% have taken this idea of site reliability engineering and learned that skill, or I'm sorry, not 74%, but 74% growth. That's a hot field, and it's moving really quickly. And why is that? Well, if we look at what it's Kubernetes. I mean, we all know Kubernetes is really turning into this rocket ship, right? Here it goes, it's taking off. And there's no reason for us to think anything different, because every time you turn around, there's something going on with Kubernetes. The difference has been that we haven't really been running data on Kubernetes. And now that's starting to change. And that's why I'm here to talk to you today, is because those times are definitely changing. And database administration is no longer about the single machine. It's working in the team in Kubernetes. So let's talk about like site reliability engineering. It is this idea that we're going from specialization to generalization. When I ran infrastructure a long time ago, it was team after team that have very specialized skills. My networking team, security team, database administration team. It was a group of people that were very specialized on a certain thing. I even had a team of people that knew how to rack up equipment in a data center. And yes, that is a specialized skill, because it took mainly organization and not killing yourself by dropping things on you, but things like how you do premise wiring and all those things is super specialized. Today, I don't think those skills are in high demand unless you're working at Amazon or Google or Azure, because that's where we're getting our infrastructure, we're renting it. So this generalization skill is really important. So you need to build your skills. And luckily, you have a lot of skills already. So here's a definition. I took this off of Red Hat has a great, like, what is an SRE? But I thought this was a great single sentence. And there are a lot of words in here. I get that. But a lot of those words you may be familiar with. So I pulled some of those out for you. And I look at this and I say, yeah, these all kind of made sense to me when I was a DBA. You know, the availability, latency, change management, emergency response, you know, getting woke up by a page at 3 a.m., capacity management. I mean, how many times have we had to do that? The capacity management was probably one of the darkest skills of the DBAs. Like building a database that will actually scale when you need it was hard. And actually that's what got me into Cassandra, because I was kind of tired of that. But I go back to like emergency response. That is a core competency of DBAs. You are going to be on call. You probably were on a pager for a long time. And that's a really key part of being an SRE. Site reliability engineering is responding to the problems that are happening, but it's in a more generalized way with a more generalized skill set. And why are you perfect for this job? Well, everything we've deployed for years and years, if you look around here, like we have microservices are deployed, web and mobile, IoT, all of these things have one thing in common. They all need a database. They need a reliable database. And you've been the person out there getting that job done. That kind of engineering skill, you're the center of the universe. Because why? Because the database is the center of the universe. Data is where everything is. If you lose your data, everything else is offline. I can lose servers in my microservices architecture. That's not a problem. But if I start losing databases, that's when things get really rough. And so you've learned the criticality, the importance of that centralized infrastructure in the infrastructure that you provide. And that's not a skill that you're going to have to learn. When I look at like the DBA skill set, this is probably one of the ones that you can't really put on LinkedIn. Is I know how to respond when things go south. And this is something you have. But we've built our machines and our, the databases that we've put together over years. And that is really about resource management and how we manage what we have. And so I think like, going back to that old Sun 450 that I had, I was managing a single server for sure. It was a really cool single server. It had a massive rack of disks in it. I think it had 2 CPUs in it, which was crazy back in the day. But I was managing those resources in a single server. And the resources that I'm managing are compute, network, and storage. That's all. Everything else is just tweaks. Compute, network, and storage are the things that you're valuable, that you have to maintain properly. And eventually when we started deploying, we migrated our databases to virtual machines and now containers. Same story. We're managing compute, network, and storage. But what's next? What's the next thing? Well, we're building virtual data centers, which do the same thing. We're managing compute, network, and storage. And you already know how to do that probably better than most, because I'll tell you, when I was installing Oracle, the things that you would do to make sure that it worked just perfectly on a single server was, that was a great art. There was a little science, but a lot of art, like kernel tweaks and all the parameters you'd put in. Oh yeah, you know what I'm talking about. But those virtual data centers that we're creating with Kubernetes, they also need that kind of love and attention and the kind of attention to detail that you can offer. So compute, network, and storage. You understand that. And guess what? That's exactly what cloud providers sell you. A database service or something that like a platform as a service running on a cloud is really just a nice veneer to sell you the one thing that they want to sell you, which is compute, network, and storage. And you know how to operate and use that really effectively and wisely. So what are the new skills that you're going to have to learn? And I've been looking at this pretty intently for about a year now, like, okay, because I know I don't want people to feel left behind. And I think that there's just this tremendous need right now for this old skill being augmented with new skills to create something really important that's needful. So what are those new skills? Well, first, I'm going to go back to that statement from Red Hat, that one thing, and I'm going to pull out a new phrase. Responsible for how code is deployed, configured, and monitored. That is really a new skill for a lot of DBAs. Maybe not everybody, but I think for a lot. Not something I did a whole lot as a DBA. But first thing I'm going to stop at is the CI/CD pipeline. Now, you may have been involved in this in some place, and CI/CD pipelines are like anything else in infrastructure. They all have their own little definitions, but I'm going to work on one for you here. So really what I want to focus on is how do we get from someone writing code to the users? And what's the process? Well, building a CI/CD pipeline, especially in a cloud native capacity, has this, the CI, the continuous integration, and the continuous deployment are all linked together so that when someone checks in code, they do a git push and they commit their code. Git commit, bam, here's my new feature, here's a bug fix. It should be automatically built. Unit tests should be automatically run against it. If they fail, they get kicked back. Integration test should be happening all the time to make sure that it works with the rest of the infrastructure that you're building with. Like that means that it works with all the parts. And then finally going into staging, probably some sort of rudimentary testing there, like just making sure that everything builds properly and compiles. But I mean, I'm sorry, not compiles, but integrates. But then finally pushing it out, the continuous deployment to production. Companies that are really good at this can do continuous deployment, like continuous all day long. Like they do multiple deployments every single day. And it doesn't result in downtime. And it really has a high level of assurance. This is a super cool competency to build, but it's also really like, it almost feels like a superpower when you get to this point, because as developers are working on code, they know that they have everything that's going to make sure that they don't put something really terrible into production. And as a site reliability engineer, you are on top of that as well. You're involved in that and you're working with people writing code to make it better. And you've done that before. Like how many times have you had a developer come up and say, hey, how does my SQL query work? Because this doesn't seem to be working very well. You're used to how this works. But getting understanding things like Jenkins or Argo and the continuous deployment environments, if it's creating containers or using Terraform, however you do it, getting that all sorted out and working is a huge skill set. The other skill I'm going to talk about is observability. And no, I'm not talking about, setting up a dashboard for your Oracle stuff. Yes, we've done that plenty. And no, that's not what I'm talking about. That's a single focus. And this is what I want to try to get you away from. It's getting away from that specialization and into generalization. What I'm talking about is total observability. So from when a user makes a request, all the way from when it goes to the database and then returns all the way back, so down and back, what's happening? And a lot of times we don't know. And observability is about that, like just knowing exactly what's happening in our infrastructure at what point. And there's some really cool projects like Open Tracing that put these injection points, like in my front end code, in my microservices, in the container libraries, in Kubernetes and databases. And then they create all of these statistics that can be used in something like Prometheus or Victoria. I think Victoria is like an interesting one as well. Now, all of these being collected in one place gives you this big picture. Say, okay, so why are things slow for users? Instead of everyone pointing their finger at each other, because you know that game, you used to be the person getting pointed at. It's the database's problem. Well, no, now with good observability, you can look at the whole thing and say, looks like we have a problem over here. Why don't we take a look at that? And this is a great skill to build. You probably already have some parts of it because you've been monitoring your databases. I mean, you probably know every $$ table there is in Oracle, right? Well, look at this. You can get even more statistics, more data. The other thing I want to talk about is just knowing the code. And that is really, I mean, getting into coding is a really important feature of an SRE. Now, you probably already have been doing some coding. Let's face it, SQL is another language, right? But whenever you look at coding as a practice, it's understanding like, how does this interact with the environment? So if I'm deploying a Python application or a Node.js application, understanding how the builds work and all those things is really just some fundamental information about code. Know the code. So where do you go next? When you want to understand this and move forward, I mean, if I've convinced you, I hope I did, where do you go next? Well, I have a few resources and they're probably not what you're thinking. First is a Cloud Native Compute Foundation. They have excellent training for Kubernetes. It's very affordable, but they have great online training and you can get certified and learn about what's going on like in Kubernetes, which translates really well as an SRE. The other place, and I love YouTube right now, you can get some great stuff off of YouTube because there's so many good creators. The amount of creators that are out there that actually, I mean, it's free education, which is mind-blowing that they're actually creating this, like Tech World with Nana. It's got this fantastic DevOps and SRE training that it's hours and hours of training, but you will get a lot of information out of it. And it's pretty good. You're like going to a classroom. So these are two immediate resources that I always go to whenever I'm trying to learn a new skill inside our SRE. And I am learning constantly as well. The other one that I'm going to offer is joining this Data on Kubernetes community. And it's an independent community. It is really picking up steam. We just had an event at KubeCon, and it's just like-minded individuals. Like, how do I run data on Kubernetes? And you can find people there, much like yourself, who love to talk about data, but are doing SRE skills, not the role, the skill. And just a great community to join in anyway. So, and joining into the community means there's a Slack or even creating content or just watching the YouTube channel as well. But I invite you to this. I spend a lot of time in this community and I would love to see you there. So that's what I had for you today. I just really want to implore you, think about the future and where we're headed. The cloud native future is really, really cool. And we would love for you to be a part of it. And if you want to do that, make that jump from DBA to SRE and feel it. Thank you.
Thank you, Patrick. If anyone would like to discuss this in more detail with Patrick, you can pop your questions in the chat. Our final keynote presenter is Dor Laor. Dor is the CEO of ScyllaDB and will be presenting on ScyllaDB Beyond Cassandra.
Hi, welcome to my talk, Scylla Beyond Cassandra. I'm Dor, CEO of ScyllaDB and co-founder of the company. Welcome. So we've been developing ScyllaDB for more than 6 years, and initially we were all about to achieve compatibility with the Cassandra API. More than a year ago, we caught up completely and we started to develop additional things. We even offer DynamoDB compatible API. So in this talk, I'd like to go over the recent development and also show you what we are developing right now, which is super exciting. So let's cover first what ScyllaDB in a nutshell, for those of you who may not know, and also cover existing functionality that went beyond Cassandra and touch about Project Circe. So in a nutshell, ScyllaDB is a real-time database. It handles big data, excels in scale. And for us, scale is hundreds of terabytes and petabytes and milliseconds of response for your P99. Today we run in the back of leading services like Zillow or Comcast, Disney Plus, Discord, and many others. In one sentence, we give you the power of Cassandra at the speed of Redis. We kept everything that's good is in Cassandra, and there's a lot of goodies in Cassandra. Like I think that Cassandra leads the industry in high availability, and we capture it all one-to-one. Cassandra leads in disaster recovery in terms of multi-data center deployments, and we do the same. And the same with scaling out to hundreds and even 1,000 nodes within the same cluster. What we do unique is we do the same at the speed of that Redis can do. So we can easily do 1 million requests per second in a single node. And the performance come out of the box. It's all automatically tuned. No need to be a PhD in order to run asynchronous. You can consume Scylla in open source, in Kubernetes, in our enterprise solution, or our as a service solution. Two interesting, super interesting and unique thing about our technology are the following. First, on the left-hand side, we have shard per core architecture. Now, shard per core, everybody do shard their clusters from cluster to servers. We do that too. But we go another level, and within the server, we also shard per CPU cores. So if you have 20 or 40 cores, they're within your single server, all of them are sharded, all of them are independent. Each shard has its own core of execution, a single thread. It's pinned to that thread. We also pin the memory, it's NUMA local, and each shard is doing its own IO for networking and for storage. So the more shards you're going to have, your performance will grow linearly, and we scale up to 100, 300 CPU cores per server. And yes, and we run on ARM, and we run even on mainframe. IBM ported us to mainframe. Another unique capability of ours is the CPU scheduler and the IO scheduler in user space. We use regular Linux, but as I said before, each CPU core is run by a single thread. And within that thread, we have a lot of action, a lot of things going on. We have the queries for reads and for write, which are low latency sensitive operations. And we have lots of data movements. In a distributed system, you need to move terabytes of data around. If the cluster expands or shrinks or there are failures, always you need to synchronize and move data around. And we're speaking about terabytes and sometimes hundreds of terabytes and even before. Now, all of these data movements are very resource heavy. So all of our schedulers measure every action, CPU action and IO action that happens in the system, because the system can overload, but usually the queries won't achieve 100% utilization. That's rare. What can achieve more than 100% utilization is the fast data movement, and we need to move data as fast as possible. So the scheduler allows us full control. So we'll always first prioritize your queries and make sure that they satisfy your real-time requirements. And later on, we'll fill the rest of the capacity of the CPU capacity and the disk capacity with the other requests that have different priorities. And we compute these priorities dynamically. They change as a function of the queue of the commits or the repair processes. We have lots of blogs around it. And these things allow us to get to nodes that can run 60 terabytes per node. So that's a lot, or use as many cores as one may have. You can find lots of data about our benchmark, whether it's versus DynamoDB or Cassandra, Google, Big Tables, and CockroachDB and others. We take a lot of pride that our benchmark are really fair. You don't really need to believe us. You can check what our customers are doing or run yourself. But we spend months of time in order to tune the competitor and to try to reach some reasonable performance that it won't be miles and miles from us. So that was still in a nutshell. Let's talk about some of the capabilities that we have beyond Cassandra. One of them is change data capture. So we want to capture all of the changes that go into a certain table, and it's enabled per table. Either it's insert or updates. It's very, very helpful. Now, the way we implemented it in Scylla is that the CDC log basically is another table. So for every table that gets CDC enabled, we add another system table that tracks the changes to that table. And when a writes come and an insert come, we may want to read the former value of the data for that particular key, because we can allow the user to ask for that we're going to capture the previous value of the data. And in such a case, there is a read. It's not mandatory. And later on, we write the new data and we piggyback that on the same nodes that will store the base table. So the performance overhead is minimal. Over the wire, there's no additional packets being sent. It's all piggybacked. And the node does two writes, but writes are very, very cheap in Scylla. Reads will go directly to the CDC table. So it's, and we're going to use the CQL protocol. So it's really easy to consume the data. We provide libraries for you to even simplify the process further. And there's a TTL, so the data will stay there for 24 hours. If you compare the Scylla CDC capabilities with other leading databases like Mongo or Dynamo and Cassandra, of course, you're going to find that we have lots of advantages. That's one of the advantages of implementing it as a latecomer. We even have additional filtering capabilities that Dynamo doesn't have, because we keep it in a regular table and you can filter the regular table like any other table. Let's talk about some other advantages in terms of elasticity. So Scylla is very elastic. You can add nodes and it's relatively simple. The nodes automatically split the data among themselves. And despite that, we have plenty of schedulers that make sure that we prioritize the queries. Sometimes it's still challenging because there is a lot of data, and a new node that joins, it has to accept all of the stream data and also process new writes and organize the data set. So you can see here that every time we add a node, we have a latency spike, and latency in the P99 goes from, in this particular session, setup from 5 milliseconds to 15. And it doesn't make us pleased. So we analyze this, and we know that there's a bunch of changes that we basically applied in order to accelerate it. So actually, the new node doesn't necessarily need to accept reads. I'm sorry. So over the streaming operation, it will only write the streaming, but reads will only go to the standing nodes. So this way, the new nodes will get better load balancing. We also have a really neat algorithm called heat-baked load balancing, because we warm up the cache of the joining nodes so we don't overwhelm them, and we let the cache slowly get warmed up. And we also pause automatically compaction, because we know that more and more data will come. We control the streaming, so we automatically pause the compaction and resume it once the streaming ends without anything that the user needs to do. And there's another super cool ability to restart streaming and decommission, because sometimes you're going to send terabytes, and if there is a failure in the way, you don't want to repeat the whole process again. The result is that it's impossible to trace when a node operation started based on the latency graph. So if you wouldn't have these markups, then it looks like really flat. And that's the newest version of Scylla on the master branch. Now, all of it is not enough for us. We like to take Scylla beyond what it is today, beyond Cassandra and beyond Dynamo. Recently, we announced a project called Project Circe, in which it means the death of eventual consistency. We announced it in our latest summit, in January, and it's a long-term project that we're working on. The main idea is to improve maintenance and improve resilience and consistency. Schema changes and topology changes in Scylla are not transactional. And that's bad because we can do it only once at a time. It was discussed in the Jepson report that we passed in December, but with this assumption of one topology change at a time. We also do want to have like dynamic shard load balancing to do it automatically. And it means that we need to split the range ownership. That's a topology change. We do have lightweight transaction that allow us to do consistent operations, but that comes with an overhead of 3 round trips, and that's bad. And since we also mimic the DynamoDB API, it does have a leader election model, and we like to follow that without any performance penalty. So we can do read, modify, write without any performance penalty. So the key idea is to adopt the Raft consensus protocol, and it will allow us to do consistent operations, maintenance operation, and better elasticity operations by having everything immediately consistent and not eventually consistent. We'll give an example. So if you have a cluster of 3 nodes and you add the 4th node, all of the nodes contribute today the ranges, and this is how we built the 4th node. But if you're going to double the cluster size and you're going to add the 5th and the 6th node, what happens is that it's not done everything in parallel, it's one at a time. So every time you add, all of the existing nodes contribute data to the joining node. And some data has traversed a long path between node number 2 to node number 4 to 5th and to the 6th node. Now, this is redundant because we knew ahead of time that we like to grow the cluster from 3 to 6 nodes. If we have transactional ability, we can make a transaction ahead of time, split all of the ranges, and kick off a command that streams the data from the 3 nodes directly to the 3 new nodes. And by doing it, it'll be all parallel and all efficient. So that's one capability. Some other capabilities are the basic ones about being able to do parallel DDL. So schema and topology changes will be transactional and immediate. The data set will be, data accesses will be strongly consistent. So you'll have linearizable capabilities and guarantees, while keeping the same high availability and partition tolerance abilities that we've been offering so far. And lastly, we also have the notion of tablets that allow us to split ranges, and that allows us to do dynamic load balancing. This whole thing is being developed, so we already completed the core Raft protocol, and now we modify each algorithm once after the other. We'll continue to do that over the course of this year. You're welcome to track our development and stay tuned, and also try to download Scylla and run it yourself. Thank you.
Thank you, Dor, for sharing with us today. That brings us to the end of today's keynotes. Thanks once again to all of our presenters and to all of you for joining us. Please don't switch off. There are still lots of great sessions over the next few hours, so make sure you check the schedule to find the ones that work best for you. Percona Live will return in 2022, hopefully in person, but at the least with a hybrid approach. Thank you for all of your open source database contributions and support, and please stay safe. Cheers.